Good evening. NASA's Lunar Reconnaissance Orbiter, LRO, celebrates 5 years imaging and studying the Moon on June the 18th. The Moon has always been a splendid sight of the night sky, and when an amateur receives a first telescope and sets it up in the garden, the Moon is often the first object to be viewed through the eyepiece. Therefore, in this month's programme, we take a look at how best to observe the Moon and also recognise some of the main craters. The study of the Moon is called selenography. Selene was the Titan goddess of the Moon. She was depicted as a woman either riding side saddle on a horse or in a chariot drawn by a pair of winged horses. Her lunar sphere or crescent was represented as either a crown set upon her head or as the folds of a raised shining cloak. Sometimes she was said to drive a team of oxen, and her lunar crescent was likened to the horns of a bull. Selene's love was the shepherd prince Endymion. The boy was granted eternal youth and immortality by Zeus and placed in a state of eternal slumber in a cave near the peak of the Lydian Mount Latmos. There his heavenly bride descended to consort with him in the night. In prehistoric times, cavemen must have seen the familiar phases of the Moon, although they could not have known what the Moon was or what caused it to change shape. Later, the Greeks and other ancient astronomers worked out the motion of the Moon and were able to predict eclipses with reasonable accuracy. The Greek philosopher Democritus, who was born in 460 BC, suggested that the Moon was mountainous and there were many suns and moons yet to be found. In the 15th century, the Italian artist and philosopher Leonardo da Vinci, who was born in 1452, correctly stated that the faint visibility of the night side of the Moon when it is in crescent phase is due to light reflected onto the Moon from the Earth. This is called earth shine. The appearance of the Moon has fascinated mankind for hundreds of years. In 1600, before the invention of the telescope, the British astronomer William Gilbert made the first known map of the Moon showing the main seas, which today are called Maria. Then came the invention of a telescope in 1609, and before the Italian astronomer Galileo Galilei made drawings of the Moon's features, it was a detailed map drawn by Thomas Harriot, who was an excellent mathematician and one-time tutor to Sir Walter Raleigh, which attracted attention. It was quite detailed, considering he used a telescope similar to Galileo's, and Galileo's own drawings of the Moon followed at the end of the year. As maps of the Moon became more detailed, they showed more surface features, and it became necessary to give some order to naming them. In 1645, the task was begun by Lagrange and Hevelius, although their ideas have not survived. Hevelius suggested that the prominent crater we know today as Plato should be called the Great Black Lake. He was the city councillor of Gdansk, Poland, who built an observatory on the roof of his house and equipped it with one of the first aerial telescopes, which was very difficult to use. They had small object glasses and very long focal lengths. The main telescope Hevelius used was 150 feet in length and was very cumbersome. Nevertheless, he was a skillful observer and produced a lunar map under a foot in diameter. The real pioneer was the Italian astronomer Giovanni Riccioli, who in 1651 named the features of the Moon in honour of scientists. His own map was about the same size as Hevelius and was largely based on observations made by Riccioli's pupil Grimaldi. Riccioli named all of the dark plains such as Mare Imbrium, Sea of Showers, Mare Tranquillitatis, Sea of Tranquility, and about 200 of the large prominent craters, including Plato, Copernicus, Eratosthenes, and Tycho. As the years passed, Giovanni Cassini drew a 21¼ inch map of the Moon in 1680. However, it was a German astronomer, Tobias Meyer, in 1775, who introduced a system of coordinates, the equivalent of latitude and longitude on the Moon, and produced an excellent 8-inch map of the lunar features, which remained the best for over 50 years. Another famous lunar observer was the German William Wolf Beer, who was a banker and astronomer from Berlin, Prussia, and the half-brother of Giacomo Beer. He built a private observatory with a 3.5-inch refractor in Tiergarten, Berlin. Together with John Heinrich Madler, he produced the first exact map of the moon, entitled Mappa Selenographica, in 1835, and in 1837 published a description of the moon. Many more observers of the moon followed, including Welsh astronomer Hugh Percy Wilkins and later Sir Patrick Moore. In 1951, Percy Wilkins compiled the largest amateur drawn map of the moon, which was 7.5 meters, 300 inches in diameter. The space age began in the autumn of 1957 with the launch of Sputnik into low Earth orbit, and a decade later, on July the 20th, 1969, Neil Armstrong and Buzz Aldrin landed on the surface of the moon and brought back rock samples from the lunar surface. Since then, a number of spacecrafts have been placed in orbit around the moon, including the Lunar Reconnaissance Orbiter and Clementine, both of which have retained some amazing views of the lunar surface. The Earth is the third planet out from the Sun, lying at a mean distance of 93.5 million miles, and takes 1 year, 365.25 days, to complete its orbital path. The two inner planets, Mercury and Venus, have no moons of their own. Beyond the Earth, Mars has 2 natural satellites, while the outer gas giants have plenty. Jupiter has 67, Saturn 150, Uranus 27, Neptune 14, and the outer dwarf planet Pluto has 5. The Moon is the Earth's only natural satellite. It is 2,927 miles in diameter and orbits our planet once in a little over 27 days at a distance of 238,000 miles. Astronomers measured the orbital period of the Moon in 2 ways. The sidereal period is the time it takes for the Moon to travel right around the sky from one specific point relative to the background stars. The sidereal period of the Moon is 27 days, 7 hours, 43 minutes. The synodic period is the time it takes the Moon to go from one full or new moon to the next, which is 29 days, 12 hours, 44 minutes. The Moon takes longer to do this because the Earth is in orbit around the Sun, taking the Moon along as its companion. Therefore, the angle of the Sun changes and it takes the Moon a little longer to catch up from one full moon to the next. If you are just setting out to observe the Moon, try to observe all of the main features on the near side from one night to the next. The numerous craters and mountain ranges, all of which can easily be seen with binoculars and small telescopes. The Earth-Moon system may be classed as a double planet because the Earth is 2.7 times bigger than the Moon and has 81 times more mass. The Moon is also locked into what astronomers call synchronous rotation, so that our satellite rotates on its axis in the same period of time it takes to orbit the Earth. This is why you can only see the same view of the Moon from your backyard, and we cannot see the far side of the Moon from the Earth, or nearly so. I say nearly because there are effects known as librations, which cause slight modifications, so that from Earth it is possible to examine 59% of the Moon's surface. The most important libration in longitude, is due to the fact that the Moon's path around the Earth is not circular but elliptical. The astronomer Johannes Kepler published 3 laws of planetary motion in 1609, the second of which states that the velocity of a planet around the Sun or a satellite around its primary depends on its distance. The closer, the faster it moves. In the case of the Moon, its distance from the Earth ranges from between about 221,000 miles at perigee to 253,000 miles at apogee. So when it is near perigee, closest to us, it is moving at its fastest speed. Therefore, from perigee, when the moon moves around its orbital path to a position of exactly 90 degrees, it is actually moved by 96 degrees because it is moving faster. This allows you to see a little way over the moon's limb. Similarly, when the moon moves to a position of exactly 90 degrees around its orbit from its apogee farthest away from us, it is only moved by 84 degrees because it is moving slower. You can then see a little over the opposite limb. Therefore, the second observing program you may like to be involved in is a recording of the libration features as they come into view at the edge of the moon's disk. This can be either sketched or photographed. As the moon moves along its celestial path, it appears to travel along the ecliptic through the constellations of the zodiac. The orbit of the moon is inclined by 5 degrees to the plane of its orbit, therefore it can be seen up to 5 degrees above or below the ecliptic in the sky. As it does so, it passes in front of various stars and the occasional planet. Astronomers call this an occultation. Some stars may only graze the edge of the moon, winking as it passes behind mountain features and ridges. This provides the amateur with a third observing program, the careful timing of occultations as they take place each evening. In addition, as the moon passes close to a bright star or planet, astronomers call this a conjunction. When they take place, conjunctions make ideal photo opportunities for astronomical photographers. If you have a moderate-sized telescope of 8 inches aperture, there are 2 further fields of research that may interest you. Keeping a careful watch for what astronomers call transient lunar phenomena, TLPs. Occasionally, small points of white light can be seen as a meteor hits the moon's surface, and there are also been reports of subtle orange glows near some of the craters, which could be an indication of volcanic activity. One magical event everyone can enjoy is watching a total eclipse of the moon when the brilliant full moon changes colour to coppery orange, even red, as the moon passes through the Earth's shadow in space. The next partial lunar eclipse visible from the UK will take place on April the 4th, 2015. There are penumbral eclipses of the moon which happen when the lunar disk passes through the Earth's lighter outer shadow. However, they are not very impressive because the moon's light dims very slightly during these events. So there are various observing programs you may like to try. The moon is so close to us, it makes it an ideal subject for the beginner, equipped with a nice pair of 10 by 50 binoculars. Even with the unaided eye, you can make out the features of the man or a rabbit in the moon. The best advice I can give you is join your local astronomical society and attend their meetings. There you will meet more experienced amateurs who can give you guidance about observing the moon. Many astronomical societies have their own moderate-sized telescopes they will allow you to use and which will allow you to see the moon close up. It may surprise you to know that the worst time to observe the lunar surface is during full moon. The appearance of a lunar feature, such as a crater or a mountain, depends very much on the angle at which sunlight strikes it. At full moon, sunlight is directly overhead, so there is little chance for the feature to cast any shadows, which means that you will not be able to see any of the finer details. When a crater is near the terminator, the dividing line between night and day, it will have much of its floor covered with shadow and it will appear very conspicuous. Therefore, as the moon waxes and grows from new moon to full moon, the best sights will be had by observing craters and mountains along the terminator as the sun rises over the surface. Then, as the moon wanes from full moon to new, you will be observing the features along the terminator as the sun sets over them. The main dark areas on the moon are the maria, or seas. Of course, there is no water on the moon and no discernible atmosphere. They were simply named after the vast open plains they appeared to be to the early astronomers. Mare Serenitatis, Sea of Serenity, Mare Frigoris, Sea of Cold, and Mare Imbrium, Sea of Rains, for example. There are tens of thousands of craters on the Moon, the majority of which have been given the names of astronomers, famous scientists and people since the invention of a telescope. The largest craters have rays, bright linear features that make them stand out from the rest, such as the crater Tycho in the Moon's south polar region, or Copernicus on the upper left quadrant of the Moon. There is a very nice computer program that you can use to help recognize all of the lunar features. It is called the Virtual Moon Atlas, and it can be downloaded free of charge from this link. The atlas covers the whole surface of the Moon in great detail, and there are lots more photographs of the craters you can download at a later date. The Virtual Lunar Atlas will simplify the next step of the learning process. To the beginner, all of the Moon's craters cause confusion because there are a lot of them and a lot of named features to remember. Therefore, the first thing you need to do is to learn your way around the Moon, and the best method is to obtain an outline map and practice. During each lunar cycle, make a list of all the main features you wish to learn, then aim to make drawings of each of them as they come into view on the terminator. During the next lunar cycle, repeat this method until you have at least 3 drawings of each feature obtained under different illumination conditions. Your survey of the Moon may take a year to complete. However, at the end of the program, you will have learned to recognize most of the craters, rills and mountains on the Moon, an achievement you can be justly proud of. When making your sketches, never try to draw too large an area on too small a scale. To make a full drawing of one of the lunar seas would be quite useless because the many craters will be too small and errors will creep in with their positions and shapes. A scale of 20 miles to the inch is about the smallest scale to use. Secondly, drawings may be either line or half-tone. Line drawings are the easiest to make using Indian ink for the shadows. Also, your drawings should be rechecked at the eyepiece if at all possible. Of course, if you are a more advanced observer, you may wish to use digital equipment or a camera to photograph the surface features, which is an ideal arrangement. When making lunar drawings, start with a low power eyepiece and sketch in the main detail, and then change to a higher power for the fine detail, and never draw in any features unless you are quite certain it exists. Record all your observations in an astronomical notebook. It is important to record your name, date and the time in Greenwich Mean Time or UT. No observation is useful without recording the telescope you used to make the observation, along with the magnification and the seeing conditions. For this, I recommend the Antoniadi scale from 1 to 5, where 1 represents superb conditions and 5 being very poor. One further point to make is the orientation of the Moon when making your observations. As seen with the naked eye or binoculars, there is no problem. North is at the top and the western edge of the Moon is on the left of the disk. However, astronomical telescopes turn the image upside down, where the 2 limbs are on opposite sides, so that south is at the top and the eastern limb is on the left. Therefore, do indicate on the size of your drawing the correct orientation of your field of view. Making timings of the occultation of stars is a useful undertaking for the amateur astronomer, because the observer can make a valuable contribution to the investigations of the motion of the Moon and the rotation of the Earth. Predictions are published yearly in the Handbook of the British Astronomical Association, while other societies publish predictions in their newsletters or on their websites. Before full moon, Predictions are given for disappearances behind the leading limb of the moon, and after full moon only for reappearances, except for the brighter stars and planets when both are given. This is because it is much easier to see the star near the unilluminated edge of the moon than near the bright illuminated limb of the lunar disk. There are various methods used by observers, one of which is to make use of a stopwatch. The watch is started at the moment of occultation. The stopwatch is then stopped on the next convenient second beat of a precise radio time or internet time signal. At this point in the program, it will be useful to give a simple survey of the moon and point out some of the main features you may wish to see this month. Here I am using the standard naked eye view of the moon, with the north at the top and west on the left side of the lunar disk. I also intend to give the size of the surface features in kilometres. It is simple enough to convert kilometres to miles. You simply multiply by 0.622. There are 20 seas or maria on the moon's near side, the majority of which are grouped together on the eastern hemisphere. Your first objective then is to learn the shape and positions of the maria. Look at their appearance and try to identify the largest craters in and around the seas. Plato, Copernicus, Eratosthenes and Archimedes in the moon's northwestern quadrant, the brilliant Rayet crater Tycho near the lunar south pole, and the crater Langranius near the eastern limb. Then learn to identify the position of some of the main mountain ranges, for example the triangular-shaped Apennines at the centre of the moon's disk and the Leibnitz Mountains range marking the southern edge of the moon. After you've done this, you will be ready to begin a more detailed survey. Let's begin near the moon's north polar region, where we find the ribbon-shaped maria called Mare Frigoris, Sea of Cold. It is easily identified by the large dark oval crater named Plato to the south, which is 101 kilometres in size and situated in the Montes Alps. Plato is best seen one day after first quarter or last quarter. The area to the north of Mare Frigoris is the north polar region of the moon, which is dominated by many craters, one of the largest being called Goldsmith, which is 121 by 73 kilometres. There is a slightly smaller crater named Barrow on its right. Following Plato around to the west, we come to a half-circular feature called the Sinus Iridium, Bay of Rainbows, which covers 400 kilometres by 242 and is very prominent. The semicircular mountain range is named the Montes Jura, which is usually identified with binoculars. The main crater in the northern rim is named Biacini, which is 38 kilometres in diameter. It is best seen 3 days after first quarter or last quarter. The short narrow sea above this is the Sinus Auroris. The large round region lying to the south of Plato, which is bordered by the Apennines to the east and the 3 large craters, Copernicus, Stadius and Eratosthenes to the south, is named the Mare Imbrium, which is Latin for Sea of Showers. In this area of the moon, the crater Copernicus is one of the most famous features. It is best seen 2 days after first quarter. Copernicus has been called the monarch of the moon and is a nice sight in small telescopes. Stadius is 70 kilometres in diameter, with low shallow walls, which is occasionally referred to as a ghostly feature. It lies on the edge of the Sinus Estium and forms a triangle with Copernicus and Eratosthenes. Eratosthenes is a 60 kilometre crater which is perfectly round and extremely deep with central elevations and marks the southern end of the lunar Apennines. Next to the triangular-shaped Apennine Mountains can be seen the prominent crater Archimedes, which is the largest of the craters on the Mare Imbrium. Archimedes is 83 kilometres in diameter, with walls extending 4,400 metres in height, and forms a trio with the nearby craters Astylis and Autolycus. It was near here in July 1971 that the Apollo 15 astronauts landed on the Moon in the Apennine Valley near Hadley Rill. Looking further over towards the western limb, we come to the Oceanus Praetorium, Ocean of Storms. It is the only one of the lunar maria to be called an Oceanus, ocean. Due to its size, Oceanus Praetorium is the largest of the maria, stretching more than 2,500 kilometres across its north-south axis and covering roughly 4 million square kilometres. The focal point of the area is the 40-kilometre crater Aristarchus, which has a prominent ray system visible during earthshine. It is also associated with transient lunar phenomenon events. The brightest feature of Aristarchus is the steep central peak. To the west is the 35-kilometre crater Herodotus, which has a rill extending away from its northern wall, which is nicely seen in small telescopes. In the north-eastern hemisphere of the Moon, the Mare Frigoris extends down into the northern edge of the Mare Serenitatis, Sea of Serenity. All of the maria here form a distorted upside-down Y feature on the Moon, which is easy to locate. The largest area is named the Mare Tranquillitatis, Sea of Tranquility, which is home to the famous Apollo landing site for Apollo 11. I particularly enjoy observing the craters Plinius and Vitruvius that lie on the boundary with the Mare Serenitatis. Plinius is an isolated circular formation with steep slopes supporting Rimmer Plinius to the north. It has a flat floor with a central mountain and is best seen 3 days after first quarter. Also of note is a large crater named Langrenius in the mid-eastern edge of the Mare Fecunditatis, Sea of Fertility. It is a tremendous walled plain with high terrace walls rising 3,000 metres, while the floor contains a bright twinned peak central mountain. Langrenius is most imposing under low light. The Mare Crisium, Sea of Crisis, lies close to the Moon's eastern limb, above and to the east of the Mare Tranquillitatis, which covers an area of 176,000 square kilometres. There are 4 prominent craters along the southwestern highlands, which make the nice views in a small telescope. The most prominent is named Firmicus, which is a 56-kilometre sized crater, best seen 3 days after new moon. The Moon's lunar highlands are covered with impact craters, and there are a lot to choose from. As your survey progresses, you will soon be able to choose your favourites that stand out among the rest. For example, the large prominent craters named Tycho and Clavius, which are best seen 1 day after first quarter. I particularly enjoy observing the 86-kilometre crater Tycho, which cannot be mistaken because of its nice system of rays extending in all directions in the south polar region of the Moon, while Clavius is one of the largest craters on the lunar surface. Clavius is easily visible in binoculars and lies directly under the crater Tycho. Clavius is a damaged circular formation with steep slopes 126 by 136 kilometres in diameter with very high walls. Just as the gardener learns the Latin names of the plants and shrubs in his borders, it is the same for the lunar observer, and very soon the craters become recognisable in their surroundings. As you identify each of the lunar features, try to take a photo of them using your mobile phone, hold the camera lens close to the eyepiece of your telescope and click the shutter. That way you will have a permanent record of all your observations. In December 2013, China landed Chang'e 3 and their lunar rover Jade Rabbit on the Moon. In our January programme, we looked at the mission and the Moon's geology in detail. That is all we have time for this month. Please visit our website, Vimeo, where you can watch all of the past shows of astronomy and space. And if you like this programme, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening. Lunar highlands. This astronomer, William Gilbert, made the first known map of the moon showing the main seas, which today are called Maria. Then came the invention of a telescope in 1609, and before the Italian astronomer Galileo Galilei made drawings of the moon's features, it was a detailed map drawn by Thomas Harriot, who was an excellent mathematician and one-time tutor to Sir Walter Raleigh, which attracted attention. It was quite detailed, considering he used a telescope similar to Galileo's, and Galileo's own drawings of the moon followed at the end of the year. As maps of the moon became more detailed, reasonable accuracy. The Greek philosopher Democritus, who was born in 460 BC, suggested that the moon was mountainous and there were many suns and moons yet to be found. In the 15th century, the Italian artist and philosopher Leonardo da Vinci, who was born in 1452, correctly stated that the faint visibility of the night side of the moon when it is in crescent phase is due to light reflected onto the moon from the earth. This is called earth shine. The appearance of the moon has fascinated mankind for hundreds of years. In 1600, before the invention of a telescope, the British team of oxen and their lunar crescent was likened to the horns of a bull. Selene's love was the shepherd prince Endymion. The boy was granted eternal youth and immortality by Zeus and placed in a state of eternal slumber in a cave near the peak of the Lydian Mount Latmos. There, his heavenly bride descended to consort with him in the night. In prehistoric times, cavemen must have seen the familiar phases of the moon, although they could not have known what the moon was or what caused it to change shape. Later, the Greeks and other ancient astronomers worked out the motion of the moon and were able to predict eclipses with light of the night sky, and when an amateur receives his first telescope and sets it up in the garden, the moon is often the first object to be viewed through the eyepiece. Therefore, in this month's programme, we take a look at how best to observe the moon and also recognise some of the main craters. The study of the moon is called selenography. Selene was the Titan goddess of the moon. She was depicted as a woman either riding side saddle on a horse or in a chariot drawn by a pair of winged horses. Her lunar sphere or crescent was represented as either a crown set upon her head or as the folds of a raised shining cloak. Sometimes she was said to drive Good evening. NASA's Lunar Reconnaissance Orbiter, LRO, celebrates 5 years imaging and studying the moon on June the 18th. The moon has always been a splendid sight.